We have two speakers for you tonight. Stijn de Ligt on my left, with the wonderful mustache, because it's November. One more day. Are you going to pick it up tomorrow? I'm going to miss it. So he's going to be talking about the benefits of using open source large language models. Stijn has only been with us for half a year, but it feels like a lifetime. Hi, welcome. He's a software engineer, and before he came to us, he was studying at the UvA at an Open University. And we have Yoshio over there, who will be following up, talking about using GPT-4 without sacrificing anyone's privacy. He's also a software engineer. He's been here for about 2 years, and he just can't shut up about generative AI for the benefit of you all. So without further ado, one more thing. So Stijn and Yoshio are going to speak back to back. So write down your notes because we'll do the Q&A after the two talks. Right, Stijn, take it away. Yeah.
Hi everyone, I'm Stijn. I don't do AI, I don't do machine learning. I'm actually just a full-stack engineer. And I started here, half a year ago, almost. But it feels like a long time. Before we dive deep into AI and machine learning, I want to talk a bit about open source and proprietary to set the stage. So we define proprietary software as software that's owned by one entity, so a corporation or one person who manages the source, who completely controls what it's used for. And the technology is kept secret. You don't have access to source code. And that creates a defense that decides to stop supporting that software. It means you're in trouble if your business model relies on it. And often this software is monetized. You have to pay for it through a subscription, through advertisements, or through just a one-time purchase. And I absolutely hate it. On the other hand, you have open source software. Open source software is not owned by one entity. It is instead democratized by having the source code public. That means that you as a community of people can maintain it and keep updating it. It removes the dependence on it. And it's completely transparent. You see what it's used for. You see exactly what happens under the hood. And usually, because you have the source code anyway, they can't really monetize it because you could build it yourself, run it, and it's free. That removes the dependency completely. And besides that, if you don't like a direction some software is taking, you can make a fork, you clone it and make changes, and then suddenly it's your own version of that software. Honing that into AI, there's some additional things to look at when an AI model is proprietary. Mostly I worry about what is it trained on, because that can create a bias, that can create censorship. And often those proprietary models don't allow any sort of direct control. It's usually through some interface that's managed by the company itself. Like ChatGPT is just an interface on the model beneath it, GPT or ChatGPT 3.5 Turbo, I don't know. And a personal pet peeve of mine is that they can release updates to the model without really giving you the choice to roll back. They can release an update tomorrow and all your prompt engineering, all that time is wasted. So I like to compare proprietary software to renting an Uber or just using any sort of taxi service, and open source software to just owning a car, something that you can take wherever you want to, do whatever you want with, and if the service stops, you lose control. If your car stops, you fix it. So a rule of thumb in this open source software, it's a sacrifice of ease of use, because it's generally a little bit less easy to use, but you gain a lot of freedom and control of the software. And it's not very strange, especially in tech. Everything I use is pretty much open source. Most frameworks for web, most frameworks for app developments are open source. So it's pretty normal, but not in AI. Another example, like a couple of months ago, Unity framework, not open source, proprietary, tried to screw over everyone that's ever used it, which obviously ended up in an open source alternative, Godot, gaining popularity rapidly. These open source software really help in keeping them tidy, because they walk back on it even after months. That interest in Godot maintains roughly at twice as high as it was before. So generally, open source, if it's not the standard yet, it will become the standard in a long time, and that is true for most software, and it will probably be true for AI as well, because I don't know if you read the news, but OpenAI had a complete meltdown a couple of weeks ago, only 1 week ago, and that just means the future is probably open source for AI as well. It's better to just jump right now. Really nice time for that one. Before I jump into the models themselves, I want to get back to the basics first on what text generation really is. And we're going to simplify it. If you're here to learn something about machine learning, you came to the wrong place. I'm going to simplify it down to something everyone can understand. We start with some input text. The sky is. This is the model. I'm not going to explain what happens underneath. It's not relevant. All you need to know is that the model only outputs one word, which would be blue. The most likely next word on the input text, the sky is, would be blue. How do you get from this, a model that's really good at predicting the next word, how do you get from this to these long-winded ChatGPT outputs? You just run it again. You move the word blue to the input, run it again, and it's the most likely next word to be, which would be or. Let's put that on a loop. The sky is blue, or sometimes during sunset red. And that's AI. That's the billion-dollar industry that has everyone talking. It's a statistically most likely next word, and then you just go on. What you might notice is that there is no assistant. And that's because the assistant doesn't exist. The assistant is a lie. It's just a word predictor. It's not a sentient assistant. It's a word predictor. So if we are to have a conversation with an assistant, what happens under the hood is that there's a system prompt, a description of the text, something like a chat between a user and an AI assistant. The assistant does whatever. Then user inputs. How do I center a div? Probably the most asked question ever. And we end it with assistant : and the word predictor starts predicting what an assistant would say. You can center a div by solution. I don't know how. So if I were, let's assume that the assistant gave the solution. And if I run this again, what happens? It's a word predictor. I can just go on what would be the next word. People, I asked before, people said, yeah, the assistant would give another solution. No, it's predicting not what the assistant would say, it's predicting the whole conversation. If I run this again, it would predict probably the next word should be the response from the user to say thanks, whatever. The model itself is not the assistant, the model is just predicting the whole conversation just as well as it's predicting the user. So that's the chat formats that you're familiar with. There's other formats like instruction where you just put it down and then it generates a response. Useful at times, but you don't have that back and forth. What's annoying is that it's still saying something like sure sometimes because it's a response, so it can be humanized. Every now and then I like to instead run custom instruct formats where I just factually describe what I'm expecting, and then I end it with these 3 quotes that denotes that there's a code block opening. And then I run the prediction engine, and it prints out only code, no assistant there. Really powerful, but you're not allowed to do that with most proprietary ones. You're just stuck to this chat format. So that was a high overview of what text generation is. That's really the technology behind ChatGPT, Copilot, and the Gmail suggestions you get. It's all that same model structure, basically. So if we're looking at open source ones, they all follow the same technology, but some of them are given free, some are not. And the most well-known open source one is LLaMa, released by Facebook. They released this in February under a research license. So you would have to sign up through a Google form, and they would decide whether you were a worthy research institution and then give you models, or they wouldn't. In my case, they didn't. Really weird, because I was doing really good research on them. But you know how these things go. The next day, it leaked on 4chan. So suddenly everyone had access to it. It's really nice.
I think we now know who leaks.
So suddenly the whole world used it anyways, and Meta kind of realized, okay, we're just going to have to give it free then, because no one was going to put me in jail if I used the leaked ones and did fun stuff with it. But if you release it to the web and start using it for commercial stuff, then it's problematic. So luckily, Facebook decided we're releasing a revamped LLaMa 2, and this time with a commercial license. So you're actually allowed to just use it for anything, make money with it, with the small notes that you're not allowed to use it for illegal purposes, which really matters to people that are already breaking the law. So they released 3 versions, 7 billion parameters, 13 billion parameters, and 70 billion parameters. Basically, it means the bigger, the more advanced, but it kind of scales saying the biggest brain is the smartest. So yeah, a giant whale is smarter than a small fruit fly, but it doesn't scale necessarily. And these 3 different sizes, it really helps depending on the hardware, because my own MacBook Pro cannot run a 70 billion parameter model. It's too big. So I have these smaller models that can run on different levels of hardware. And it's mostly down to the RAM requirements, which is these are probably very shocking numbers to people that are familiar with how hardware scales. So 70 billion parameters would need 280 gigs. And a regular format model would even have to run on a GPU, so that would be VRAM. There is not a single GPU on the market that could handle this, not even this one. So that's really annoying. Luckily, you can compress the models effectively. Like, image compression, where a large image gets compressed, you have some artifacts, but overall the roughly same image comes out and it's 1,000 times smaller in size. You can do that on machine learning models as well, and that will be called quantization. And then suddenly those RAM requirements go way down. So a 7 and 13 billion parameter model would suddenly be able to be run locally on my machine. 70 is still way out of reach. And just rule of thumb, it's an overgeneralization, but quantization is kind of the same thing as compression. That does require different formats of models. So if I want to download a special model, so that LLaMa 2 13 billion parameter model, this would be the regular version of, that requires like 28 gigs. What was it? 52 gigs. And this is a quantized format, GGUF, that allows me to run it locally. And since it's open source, people can just download the original model, run a script through it, and quantize it, and just publish it themselves. You don't have to do the quantization yourself. And there's a bit of an information dump, but it might be important for some people, and that's the file types. You have the GGUF file type like you just saw. You need to load them with the module called LLaMa CPP, and then you can run it on your CPU, which is really nice if you have a MacBook. There's also the GPTQ format that can be run on GPUs, which is much, much faster, but you need more special hardware. And a normal model would generally be a safe tensors file type. So there's going to be a little bit of a code example, but the code is really simple, so just stick with me. We use the LLaMa CPP package that just does everything for me. It's really nice. I've a model downloaded from Hugging Face. It's called LLaMa 2 13B Chat. So it's a version that's really good at having that assistant back and forth. GTUF format, and I use LLaMa CPP to load it. And note the n underscore CTX. That is the context window. So a language model can only have a set context length. That's how much it remembers. In this case, it's 4,000 tokens. That can scale, but this model, most LLaMa models only support up to 4,000. So I continue with that. It's in the memory now. I can work with it. I give a prompt. You just pure text, conversation between a user and an AI assistant. And then I run it with create completion. And notice the stop token user. If I wouldn't pass that, it would just continue on, generate the whole conversation. This way, it only generates the outputs of the assistant. So if I print the output, it's here it is. I came up with a poem because I asked it, but well, the code is pretty enough. You don't need to see the poem. Alternatively, with another format, the custom instruction format, I ask it to write the Python code for me, print all prime numbers. I denote it on the end with the opening of a code block so that it only outputs the Python file. I ask it to stop on those 3 again. And I increase the max number of tokens. On the previous one, I was at 512, I think. Yeah. And here, it's probably going over that, so I increase it to 10,000. And if I print it now, what comes out is pure Python code, which is funny because this is a Python script generating Python code. So if you write it to a file and include that file, you can run the code that was generated in the script directly. So you have a script writing itself. Yeah, that's AGI. So mostly I've talked about LLaMa. It's one of the foundation models. Foundation model is built from the ground up. Potentially, each of them have different architectures, different licenses, what you're allowed to use it for. And the most well-known ones are obviously LLaMa, but before that there was Bloom, which is much, much bigger than LLaMa, but apparently not as good because I never really use it. Also uses a different architecture, so you're not allowed to use the same tools for it. At some point this year, Falcon came out, uses the LLaMa architecture, so you can use the good tools like LLaMa CPP still on it. Same for this one. The Yi model came out last week and has a huge context size. That's really nice. And Mistral came out a couple of days ago, I believe. No, that was a fine-tune of Mistral, but also well.
You mentioned a huge context size.
Yeah, so that's the. So I give it here a context window.
Yeah, the number of tokens.
The LLaMa model is up to 4,000, and the Yi model up to 200,000. So. And beyond those foundation models, people can fine-tune them, which means you just take one of the foundation models, like LLaMa 2, you add some additional data. Like in this case, I added some programming data, some code that I used from one of my repositories, and out comes a new and improved model that is now much better at coding. This is the family tree of the model called Code LLaMa. It's just LLaMa with, for example, some code as input and some special Python code, and out comes a model that is really good at outputting Python code. And this is actually one of the few models that is beating GPT-4, but only at that special task, because fine-tuning doesn't make the model better in general. It makes it better in specific tasks. So what you train it on. So if you were to train it on code, it gets better at coding. If you train it on poems, it gets better at that. If you train it on facts or something, it's educational. And this isn't a technique that's unique for large language models. It's also on image generation and really just all sorts of neural networks. You can find all this, foundation models, the variants of them, fine-tuned versions of them, on Hugging Face. It's like GitHub, but for machine learning. You can find image to text, text to video, any sort of model, not just language models. Yeah, if you want to stay up to date with the open source community, I recommend following the blog, because there are a lot of, if something's good, they tend to make a post about it. And I also use some of their libraries sometimes, so I can recommend those. Also, one of the things they have is this leaderboards, language model leaderboards, which I don't really like, but it's the best we have. It's like democracy. They have these different tests that they run the models through, and depending on how many questions or whatever it has right, it gets a score. Unfortunately, people can train the models on these tests, and then you get overfitted models, and it's a mess. You see huge changes, like the E model is at the top here, but a couple of weeks later, it was way down. But it's the best we have to get some estimate of whether a model is good or not. So you don't know how to code, you can still use these models. So there's interfaces to just work with them like you work with ChatGPT. And probably the easiest one to work with is this one, LLM Studio. It has built-in downloading of the models, so you can just browse your models in there. Just way the easiest. But it does limit your freedom because they don't allow much custom prompting, or you have to set it up. It's pretty difficult. So I don't really like it. I tend to stick to this GitHub page, text generation web UI. You need to know something about the command line to install it, but once you do, it's probably the most free one to work with. It has a lot of extensions like text to speech and stuff. And say you want to move off your local device, because unless if you have a strong PC, you can't run all models, then you have to deploy it on a server somewhere with better hardware. So I like to use Runbot. They have templates, so you can just pick a template, text generation web UI. That's the interface I just showed. And then pick a server with whatever GPU you want, and from there run it. But you have to take into account that, first of all, it costs money to host this, and second, safety, because you're running it on someone else's PC, basically. That was all. Questions will be for later. So.
Yes, thank you. Okay, well, where I am now. We just had a really nice talk from Stijn talking about open source LLMs and why we should use them and everything like that. And I have to be a bit of a buzzkill, because what if you still need to use GPT-4? I mean, open source models are getting progressively better and better, but there are many cases where GPT-4 it actually allows you to do certain tasks. So these open source models, they have certain limitations. For example, in terms of multilingual support, they're very, very limited. So an example would be with LLaMa 2, like if you want to try to get any Dutch out of it, well, you might as well just kneel and beg for your life, because that thing is really not trained to do so. If you do manage to get something out of it, usually it's a bit of gibberish. There's a lot of spelling mistakes, errors, grammatical errors. And another reason that it might not be good for your use case is simply because it doesn't meet your quality requirements, right? I mean, we all know that classification tasks, for example, are significantly better performed by GPT-4 than they are done by these open source models. Okay, well, kind of depressing news, right? Well, what could we do to use, well, like, let's say we have to use GPT-4, but what could we do to still overcome this sort of privacy barrier? How could we still be considerate of this privacy, or try to make some kind of best effort attempt at taking care of our users' privacy, or our own privacy for that matter? And there are essentially two options that we can pick here. The first one being, and I'm just going to scope it down to GPT-4 and OpenAI, but this essentially goes for almost every proprietary LLM. And that is, usually they have some kind of exemption. In the case of OpenAI, they do. The only way, however, you can get that exemption, an exemption here means essentially nothing of your data gets stored. So ChatGPT gives you back the response, but nothing is logged, nothing is stored. Great, but you need to be a Microsoft Enterprise client, and well, that's a pretty big license to pay for. So I can imagine that not everyone has that. So the other option that you then have is actually pseudo-anonymization, which essentially is you have your data and there are sensitive information in it, and you replace those with placeholder values. Well, okay, sounds a bit vague. Let me take an example. So here I have hypothetically some sensitive user input data. Yoshio went to the office of Q42 in Amsterdam. And let's say what is sensitive here is Yoshio, Q42, Amsterdam. Well, the pseudo-anonymized input or the pseudo-anonymized version of that looks like this. Bracket name, bracket company, bracket location. Okay, well, why is this useful? Well, imagine we take that type of thing and we just hypothetically say something to GPT-4, hey, only return me the office. And what it's going to then return is something like office of bracket company. And that's actually super useful because once you have that response, you can you can basically replace that bracket company with the original value that you know. And so GPT-4 essentially has enough semantics to reason and give you a good answer. But at the same time, it doesn't know exactly what it is. And yeah, you're just able to plug in back your values. And that's how you could kind of circumvent this situation. Now, the thing that is a bit less about pseudo-anonymized or pseudo-anonymization is they're not perfect. So you'll never get like 100% pseudo-anonymization for your input. So that means some stuffs will just leak through. But let's say you do take this route. What can we pick in there then? So there are quite a lot of models actually, or quite a lot of things that you could pick here. But these are kind of the big boys. Microsoft Presidio, which is a open source model by Microsoft, actually developed several years ago, and it's super, super good at entity recognition and basically pseudo-anonymization. Another one is open source LLaMa, for example, what Stijn talked about, the LLaMa models. You could also make your own custom model, or you could fine-tune models to better perform at pseudo-anonymization for your use case. That's also another route. But essentially, each of these have many pros, many cons, and there is no there is no way to fully document all of the pros and cons for each use case, because each use case is just so different. So I think the best way to actually go through this and make you get a feeling for what all of these models are and how they kind of work, or more specifically, how you have to deal in this with this situation, is a use case is by looking at a real use case, PostNL. So PostNL is one of our clients. We did a use case, or we had a AI use case at them. Essentially, we built the mobile app for PostNL quite a lot of years now at Q42, and we came up with this feature where essentially you can scan government letters. Like here, I hope it's going to work though. Does it work like this? All right, just the classic tap done. So we made this prototype feature where essentially you can scan whatever letter, but in this case, it's a government letter. And then you can get a summary of it, some important bullet points, and you can view an entire translation, you can view actions, you can chat with the letter. Now, it's all cool and all. But it's all powered by ChatGPT in this case. Now, all of this data in here is kind of, we used placeholder values, so these are not real data. But yeah, we showed this to PostNL after we were done with the prototype, and they really loved it. And the thing is here that for about 15% of the Dutch population, they don't understand government letters because they have low literacy skills. And there are many people who are new to the language, like people such as expats, for example, to whom these government letters are just not accessible. So, well, that's why we kind of built this case. And essentially what it does is translation, summarization, and a lot of other things. So after this prototype, we went on and continued with it. But PostNL had a very big hurdle, or we actually have a big hurdle in general, which is just privacy. I mean, these letters, they're going to contain super sensitive information, right? Like social security numbers, your name and your social security number, even worse. So we want to, we want to shield that off from ChatGPT as much as possible. And we want minimal hallucinations because these are government letters. So we want it to be as close as possible to the original source, right? So we would just use open source models because they're usually less good. It potentially introduces more hallucinations. Finally, it needs to be multilingual, and we have about 2 days to make a small prototype and show some promising results towards whether we're able to even do this. And if we kind of go back to that flowchart and plug in these requirements, we get this situation. GPT-4 open source LLM, well, I kind of already said it. We need minimal hallucinations and we need multilingual support. So open source is not going to cut it. Next up, we have the exemption versus pseudo-anonymization. Exemption is not going to work in this case. So unfortunately, we have to move to the different path, which is pseudo-anonymization. And here we face these 3 options. Now, one of them, the last one, the custom model, with 2 days time to make a small prototype, make it work pretty good. Yeah, in 2 days, you're not going to build your own model. So that one's being crossed out. So we're left with Microsoft Studio and open source LLMs. And essentially, if we look at this particular use case, then the pros that we see is, or I set up the pros and cons here. And for Presidio, it essentially has a proven track record. It is very, very good at doing this type of task. However, the downside of it is it's maybe a little bit too good in this case. Because, for example, imagine we have a government letter with Belastingdienst, which is the tax office, or from the Dutch government, and it will actually label Dutch, and it will actually label Belastingdienst as entities that need to be replaced by just the word company or the word country. And if we're going to send it to ChatGPT, then you can imagine that if we did keep Belastingdienst, did keep Dutch in there, it would probably result in a much better result, right? So it's a little bit too aggressive in that sense. Finally, there's some part about custom data types, but I don't have to dive into that one. But if we go to open source LLMs, they are context aware. So they understand that, okay, this looks like a government letter. In a government letter, Belastingdienst is a pretty common term. It doesn't have anything to do with being sensitive. So we can just keep that. At least that's our hypothesis. And it actually also does so in some sense, it does some flexible pseudo-anonymization. And it can detect that by itself, rather than having to build your own custom data types for everything. With custom data types, I, for example, mean Presidio is really trained on American information, but Dutch government letters are very different from American government letters, for example. So, or social security numbers, like they're just totally different sequences. However, downside of open source LLM, at the time that we were doing it, there was no proven track record whatsoever. You couldn't find any article about it. So, well, we still went to the open source LLM because we had to use it either way, even if we would use Presidio. And I just kind of want to dive into a bit of code of how that looks like. So first, a brief overview of the prototype. So we have our app here that scans the government letter. We have that little cloud, which is our server, and that has to do the pseudo-anonymization. It sends the pseudo-anonymized version of the prompt to ChatGPT, and back when we get a response back, we're going to put the original values back where the placeholders were. And the user will never notice that anything was anonymized in there, but we did. So that endpoint, that little cloud, essentially contains this. We build up our prompt, and I think it's good if I just dive into that prompt real quick. So that looks like this. So there's this, it has an input parameter. Are you guys able, by the way, to see this from the back, or is it very, very small?
Hardly see it from here.
You can barely see it from here. Okay.
I do have bad eyes.
Okay. Okay, that's a bit unfortunate, but essentially this is, I'm not sure if we could, but maybe give it a try. And otherwise, I could, of course, also just do this.
Sorry to be a bother. Thank you.
This will do?
Yeah.
All right, cool. So this is the system prompt. We get, well, you see the first parameter, which is the user prompt. That's just essentially the input from the user. I just instructed to extract personal identifiers from the letter of a recipient. And the assistant never gives additional explanation. Well, like any LLM just always has to do that stupid confirmation of like, oh, yes, I can do this for you. And then it gives you the results. And like, preferably, I don't want that. So that's why I added that part. And then I just do a few, I give a few examples of what it needs to look like. So, for example, there's some kind of Dutch letter. It's a bit larger than what you actually see here. And subsequently, the assistant should return something like name, Ritter, personal number, blah, 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 blah. And we give a few of these examples in the prompt. So we kind of guide it more into following this pattern. And yeah, essentially, that is actually what the request consists of. And if we then go back, it's still a bit large, but that's fine. And if we go back and we have built that request, we can just send that to some LLaMa endpoint. Stijn just mentioned you can run it on your own machine, but you could also technically host it in Runpod or whatever. That's what we did because this was just a small experiment and it was just the fastest way to get this done. And afterwards, we clean up the response. And what that entails in this situation is basically, we don't get some nice JSON back often. We had to, at the time, there was no fine-tuned JSON version of LLaMA 2. So it just at best would give you a set of bullet points. And it would just be first name, Yoshio, and so forth and so on. So I had to do some cleaning up with that and build up some kind of data type or data structure with that. So that's the cleaning up. And then we have those placeholders. And once we have those, it's just really a matter of sending it to ChatGPT. Once it comes back, we just literally replace everything we can find with the placeholders that we have and the original values. And then I think I can kind of go back to this. So evaluation, how good did this actually perform? Well, we evaluated on, of course, Dutch government letters, 5 of them, 1 bank letter, and 1 insurance letter. And what we found was that we tested it on, by the way, LLaMA 2 models, all of the versions, and we tested it on Falcon. But I left Falcon out because it just didn't perform even close to any of this. So what you see here is how much sensitive info was basically missed by the model. So this would mean, for example, my first name was not captured by the model. And LLaMA to the 7 billion chat, which is the smallest model, well, makes sense that it performs not particularly good. But the 13 billion chat, for example, which is interesting, actually performed better than the super large model, the 70 billion chat. So that's a pretty interesting insight. And if we go to some other statistics, like how many false positives did it make? And in this situation, a false positive is something like the Dutch government or Belastingdienst. Like those are things I don't want to remove from the letter. I want to give that to ChatGPT so it can give a better response. So, and what we saw there as well is that the 7 billion chat like totally went ham, made a lot of false positives. 70 billion actually made a lot of false positives, but the 13 billion chat actually made very minimal false positives. It just, in every letter, about 1 or 2 entities were false positives, and that's really, really good. Okay, so finally, the last one is processing time. Like, if you have this step between your app and ChatGPT, well, we all know ChatGPT already takes time by itself. Well, adding this step in between also is going to incur some performance cost, of course, right? Time. And we want to keep that as minimal as possible. And, well, needless to say, the 7 billion, the smallest model is the fastest. The bigger the model you go, slower they are. But there's a huge gap between 13 billion to 70 billion. The gap between 7 billion and 13 billion isn't actually that big. So after, like, if looking at everything altogether, the best performance was actually LLaMa to 13 billion. And, well, these are kind of already statistics I showed to you. So the conclusion of all of this is, in the beginning, we didn't know if this was going to work at all. But it seems that LLaMa 2 is actually very, very capable of doing pseudo-anonymization. And it was very easy to set up because we were able to just do it in 2 days easily. And finally, an interesting insight is that going for a bigger model doesn't necessarily mean that it's going to have better performance. There are many fine-tuned models out there that actually perform incredibly well on 13 billion chat as well. Now, that kind of brings to an interesting next step in the future, perhaps that we could fine-tune a LLaMa 2 model of our own and make this even better than it already is. So, I hope that was helpful to you guys, and thank you for listening.
Thanks, Stijn. Hey, Yoshio, I don't think that was half the buzzkill you presented at. It was going to be so thank you for that. And Stijn, yours wasn't nearly as overtime as much as you thought. Perfect. Okay. I'm assuming you all have a lot of questions, so take it away.
Michelle, for you, the second part. The most is about the order of the person identifying information. How well does that compared to software that does that?
Comparison to
it misses in your graph. It said it misses about a quarter of the person identifying information.
Yeah, the 7 billion.
Performance of models that are or piece of software that do this task. Is it like a quarter?
Oh, what the standard is in this area? Yeah. So the standard is roughly somewhere around 90%, or actually the standard is roughly in the sense about a little bit less than 10%. So seeing that the 13 billion chat gets to 9% is very, very impressive from that point of view. Yeah.
So when you say other software, what is that? What is that benchmark? Is that like dedicated?
So that could be Presidio, for example, or fine-tuned models potentially.
Okay. Was another question there?
Yeah, I'm just curious because you said earlier that the model doesn't do or isn't multilingual. Were these Dutch letters or English?
Yeah, that's a very, very good question. So the funny part about it is you cannot get any Dutch out of this model, apparently. But it understands Dutch very, very well, which is really strange. So that really allowed us to actually use it for this case. Because all these government letters were Dutch indeed. Yeah, none of them were English.
Here's how it would work if we try to use like a translation API, like translate it to English. Like maybe a bit better or not.
Well, you could do a translation, for example. However, there are certain. Well, the thing is, even if you do a translation, or if you would use a translation API, then you would be sending that translation with the sensitive info to that API, right? Or maybe you can have some kind of other your own model. But even in such a situation, it would really, really work for translations, actually. Because once you try to go to summarizations, yeah, there's no local model that can do that type of thing. So hence that's why it was, but it's a valid thing.
To me, understanding Dutch and not speaking it is a good potential expat experience here now. Okay. You had a question.
Yes, you showed us 3 benchmarks where the 13 billion model won. Were that all the bunch, or were there cases where biggest did win in something in performance? Or?
So I have to say that so with this evaluation data set was about 6 or 7 letters, which is not like, it's not crazy much either, right? And I saw that the gap in false positives between 70 billion and 13 billion were like, they weren't really big, weren't as big as I thought. So I think if we would do it on like a larger evaluation data set, I think it would get pretty close on that part. But I don't think it would do better from
so far it doesn't look like the bigger data set has any use at
almost for this particular use case.
Of course,
not at all. Yeah.
They tend to be better at factual stuff than bigger models. Not necessarily understanding just factual stuff, but I think it's a misuse of language models to include factual stuff at all.
Great. But linked to that, you did this in 2 days. How much knowledge did you have before you went into this? Because I mean,
so to give a bit of a primer, I didn't really explain much about myself, but I've been doing quite a lot of ML projects at Q42. But stitching this together, I mean, 2 days wasn't like that crazy. And most of the time actually went into the evaluation part. Just setting it up, it was maybe like a day or something. But evaluation, because you have to manually go through everything and check, oh yeah, is this gone? Is this a false positive? Blah, blah, blah. That really takes a lot of time. And so I think it's a very doable task for an all-round software engineer to be able to do.
Get it back in the back.
Yeah, it's just, I think one of the ways this all points is down the line we'll decompose these jobs into smaller tasks and have fine-tuned experts doing little pieces of the task. But the question is, when you look at the benchmark tables, there's a real difficulty with little expert models in that they're going to be terrible, woeful at all the benchmarks, because you only want them to be really, really good at that specific thing, like translating from Dutch to English or name entity recognition or whatever. How do we go about building frameworks to test our experts? You know, because we want to use open source models in this way. We need to be able to do it. And there's, you know, in software development as a whole, we've got testing frameworks, we've got approaches to testing. We know what to do. Do you have any thoughts about how we get there?
Yeah, that's the big question. How to what do we call this? How to evaluate. Yeah, that's still a question that's to be answered right now. These separate tests are the way to go, and that leaderboard that I showed, that was a lot of different tests, but you could have tests that are for just one subject. So you could have a test for coding, a test for what we call entity recognition, and then make separate leaderboards for that. That's currently the way to go.
Yeah, I think there are also 2 approaches in here. I mean, first, a lot of people use LLMs for existing situations, actually, where you already have existing benchmarks with older models that previously existed. So you could benchmark it against that. That's one way to do it. Another, like the abuse that's happening on Hugging Face leaderboards, essentially, like right now, what people do to figure out whether it's actually kind of a good model is just by trying it out themselves and just realizing, okay, this thing actually is kind of crappy. But I think in the future we could have sort of evaluation data sets that are new and are maybe somehow just randomized in some way or form, such that nobody can really overfit on that particular data set and show like these false statistics, essentially. Right. So
Yeah, question for Stijn. On the fine tuning you did, I guess a few questions on it. First, how did you prepare that data? What did sort of the average case look like that you were testing and training on? And then did you are you saying fine tuning is in like you're allowing the weights to be readjusted, or did you make a LoRa?
I didn't make any fine tunes.
Okay.
I just use fine tuned models, fine tunes from the Hugging Face form. So
for the code.
Yeah.
Okay.
There was another question in the back.
Yeah, correct. Well, judging just on the basically the table you just showed on the results part. So you only evaluate basically the false positives, but wouldn't be also false negatives more important than false positives?
So that's a very good question. It depends on it depends on your evaluation metric, right? Usually you have a set, or usually just even one most important evaluation metric that you want to really focus on, and that needs to be perfect. And in this case, it was the one that is about false positive, which was recall. Ideally, though, you also take into account the false negatives in the situation. I didn't really look much at that part, but I think for a future study, that would be, to make it even more solid, the whole story, that would also be required to do so. But from my initial observations, I didn't see many of them, hence I didn't pursue that route.
Okay, the other questions?
Yeah, I still had a remark about benchmarking. I think the arena one that's on the Hugging Face is actually pretty tamper-proof because it just shows the two competing results to a human.
Yeah.
And then they calculate the ELO rating on that. So So good things are happening in the world.
Definitely.
I also have an arena one where GPT-4 ranks the one, which is that was actually the best score there is, but that means that there's a ceiling of GPT-4 on how good a model can be evaluated. But that was the most reliable test I saw.
Well, it's debatable whether you can overfit on fooling GPT-4, I suppose. But
yeah,
that's interesting.
Something that would be trained on GPT outputs would perform better.
Yeah. And I still have a very practical question. Is this good enough for this use case? Like, did the customer like it?
It's a very, very good question. So basically what we communicated to PostNL is that the goal was really to kind of show that this is a promising route to go to. And the thing with pseudo-anonymization, like I said in the beginning, like you can never get it perfect. There's no way. So they'll have to accept that either way. And the real question here really is to PostNL, like, well, what does that percentage need to be? Does it need to be 5%, less than 5%? It needs to be less than 3%. But either way, they have to pick it up in some kind of privacy policy and so on about the risks of it. But we've communicated to PostNL that we were able to, via fine-tuning, make this performance even better potentially. So, hope that answers the question.
Yes, it's interesting. I do think the results are very impressive, by the way, so it's very
cool. Thank you.
But indeed, I think for legal purposes, basically the percentage needs to be 0%, right? And the other side is also that when using the OpenAI APIs, I believe they keep the data for 30 days only for issues.
Yeah.
But they don't retrain models on that data.
Yeah, that's true. Some clients don't care about it. PostNL does. So for PostNL, like they don't want it to be stored anywhere at all. So unless they own it themselves.
Doesn't PostNL, wouldn't they have an MS Enterprise license? Really?
That's a very...
Let's dive into the details of what PostNL was after the recording. There's one more question? Yeah.
Super impressive presentation. I just want to ask, can you comment stuff this time? So can you comment more on the pricing? When does it start to make much more sense in terms of like open source models?
Right now with the new pricing for OpenAI, it's that's very competitive pricing to hosting it yourself. So in terms of cost, it's you might even be at a loss if you don't have enough users to have the server running. So in terms of pricing, it's definitely not competitive right now. But that's since like a month, I think they revamped the pricing.
You have another question here?
Well, it's related to the pricing of hosting it on Rubo or Runpod, sorry. I saw a price of 29 cents an hour, but what is that hour composed of? I mean, is that queries, processing time, CPU time?
You start with pods, and then you close it when you're done. So I use it for just fidgeting, basically.
It's not CPU time. It's literal clock time.
Yeah.
Ah.
Yeah. You're really starting to warm up. I like it. So we're gonna go the whole night long. Okay, go ahead.
Since we're talking about the pricing, it's sort of looking for, and Runpod has it, but the cold start is too bad. Have you seen any serverless that? Runpod tries, but
I haven't seen that from Runpod yet. But like a serverless, but with like 30 gigs of RAM doesn't exist, and you need strong CPUs.
It does in about 90 seconds.
Even then, like,
but yeah, it's not.
Loading the model takes time, so you would have, since serverless means rebooting server requests, you would have a lot of overhead on loading the model itself.
Well, you can have the network GPU. And that.
Also, by the way, like, serverless has a lot of requirements on the size of the pod. You call it not a server, a pod. It's called.
Yeah.
So you cannot put a model that is 8 gigs of downloads into serverless. Not in existing architectures.
I don't know about you, but I'm getting thirsty, so I'm gonna like 3 more questions, and then we're gonna wrap it up here, and we can still talk it over with drinks. So yeah, you were first.
Yeah, thanks. So I like it a lot, but I'm a bit puzzled. I don't like Richard Stallman, for starters, but I do like open source, and I don't think that LLaMa is open source.
No, that is a good one, because that depends on your definition.
Well, there's one definition that it comes with 4 freedoms, and the first freedom is you can use it any way you want, and that's out of the window. You can't use it commercially, for example.
LLaMa 2 is commercially, you're allowed. You're not allowed if you have more than 700.
Exactly, there's a but, and there's no but in it. It's not open source, it really is not. Bart and BERT are open source, but I'm a bit puzzled about LLaMa being called open source.
It's the model itself. If you think it's not open source, I understand. I agree. I'm more talking about the architecture around it as well. Like, so LLaMa CPP has it in the name. It is used by other models. So the Mistral model, that is, I believe, Apache 2.0, which is that's open source.
That's open source, yeah.
So, and that uses the same architecture. So I'm looking at it like a wider community rather than focusing on just the LLaMa models, because they're not even the best right now.
Okay.
I believe, like you saw, the Yi model, which is also Apache 2.0, is beating this. Okay, but yeah, it's a sketchy agreement license that they have.
We'll change the title to open source-ish. Yeah. Yeah, the question.
Going back to the benchmarking itself, what's your interpretation on why the 13 billion chat worked better than the 70 billion one? For this use case is also okay, because you were saying something like 70 billion works better for the actual kind of use cases. Is there more additional thoughts on your interpretation?
I don't have a super deep ML answer to that. Maybe it's a bit like a situation of, it's a totally terrible metaphor, but if you have an incredibly smart human who tries to answer your question a little bit too good, as opposed to someone who has a more simpleton mind, perhaps. And maybe, like, that's kind of how I look at it so far. But I haven't didn't go super deep into it.
You need a simpler mind than yours to answer the question.
Yes, yeah, for sure.
No, I was just thinking maybe there is a categorization of the use cases itself, which you can bucket into why this might work better.
I have an example. Like if I ask a smaller model if it knows Stijn de Ligt to me, it says no. If I ask a 70 billion model if he knows Stijn de Ligt, he says it's a football player because of Matthijs de Ligt, which is wrong, but it somehow included Matthijs de Ligt in its model size.
You don't know too much about
good. So at some point, it knows too much for its own good.
We're going to go to our final question, and you have one in the back.
Yeah, about the anonymization problem. I'm curious, have you thought about how you're going to monitor the model? Because the results that you provided us, it's a very small data set, and practically, how are you going to monitor the model in the future?
Yeah, so what we first want to do is actually go for a pilot with a small subset of users. In which case we have permission to at least see what information is being extracted, and on the basis of that we want to do another benchmarking and see like how does it actually perform on like large data sets and a large evaluation. So that I hope that answers the question a bit.
I think it does. I want to wrap it up here. You can feel free to hang around and take another beer and chat to Stijn and Yoshio will be around. Thank you for being a captive audience, and thanks to Stijn and Yoshio.